Now we think about the graph of y equals 1 over x. Now this is defined if x is negative or if x is positive. I'm only going to worry about the first quadrant here. If we can graph this in the first quadrant, then symmetries. This is symmetric about the origin, as you can easily test. Symmetries will take care of the rest. So what do we have? Well, here's x and here's y. It's clear that if x equals 1, then y is going to 1. 1 divided by 1 equals 1. So let's think about what would happen now if x equals 1/2. That would correspond to x being this big. How many times does that go into 1? Well, that goes into 1 twice, or you can think about here. Doesn't matter. And that means that the result is going to be 2. Okay? Now let's cut that in half. If that's 1/4. Then it's going to go into 1 4 times. 4, can you see it there? Okay. 4 times, so we're going to have to go twice as high on the graph. That's going to put us up to 4. So we have the point 1/2 to 1/4, 4, etc. What's going to happen if I cut that in half again? Well, I cut this in half, it's going to go into 1 twice as many times. And that's going to put us up off the edge of the board. So we see that what's going to happen every time we cut this number in half, this number is going to double, and the doubling increases the number by more each time. We double this, we get all the way up to here. If we double that, we're up through the ceiling. And we can continue to double that ad infinitum. We can continue to double that as long as we wish. We can continue to cut this in half as long as we wish, which allows us to double this as long as we wish. We never get to x equals 0, so we never get to the y-axis. Instead, we form a vertical asymptote with the y-axis. Now what happens if we go this way? Let's let x equal 2. So if x equals 2, well, 1 over x is going to be 1/2. If we go out, so that's going to give us a point that's 1/2 of a unit high. Okay? If x equals 4, then we're going to get 1 over 4, which puts us to a point 1/4 as high. And so on. We see that every time we double this x number, we're going to cut the y number in half. It's going to continue being cut in half forever. We never get to the x-axis, although we get to the limit where we can't draw the point because the x-axis, as we draw it, has some thickness, and these points very rapidly get so close to the x-axis that they're going to be inside of the line that we draw to represent the x-axis. So we're going to get this horizontal asymptote. Now your text shows you the rest of what you need to graph this function. You just come down into the third quadrant here and graph a reflection through the origin of what we got in the first quadrant. We'll have then an asymptote toward the negative y-axis and an asymptote toward the negative x-axis. So and this asymptote is a vertical asymptote. And this axis is a horizontal asymptote.